Okay, guys, we're going to look at the nuclear game now. So, the nuclear game says that there are two countries poised for nuclear war, and there is some number n bombs available on the black market. Okay. So before a country decides to launch a bomb, it must consider whether it can survive the retaliation of the enemy, right? So we're going to assume that each country can choose to buy, then immediately launch an attack. Okay? And we're also going to assume that they can buy and immediately launch one or two bombs. Nothing more. All right. So they can only launch one or two buy and launch one or two bombs at a time. Okay? So, and each player expects the opponent to retaliate after the launch. And the rules of the game are that whichever player launches last wins. Okay, so whoever has more, not necessarily more, but whoever launches last wins, i.e., the last mover wins the game. Okay? So, how do we solve this? So let's suppose n equals 1. Okay? If n equals 1, this means that the game has a unique sub-game perfect equilibrium where player 1 takes one bomb, launches it, and wins. So for n equals 1, player 1 wins. How about for n equals 2? So for n equals 1, player 1 has the first move, and the players can either choose 1 or 2. They can either choose 1 or 2 bombs at a time. So player 1 chooses 1 and launches it, so he wins. He's the first and last mover. For n equals 2, player 1, you can either have player 1 takes 2 bombs and launches them and wins. Or, sorry, I don't know why the keyword is here. Or you can have player 1 takes 1 bomb. And then player 2 takes 1 bomb. And then player 2 wins. But this means that player 1 loses. Hence, this is not a best response from player 1, therefore not a subgame perfect equilibrium. Okay, so for n equals 2, the subgame perfect equilibrium is that player 1 takes 2 bombs, launches them, and wins.